Hey, this is Randy. Today we're going to learn how to multiply binomials by polynomials. Basically, we're just going to do the distributive property multiple times. Let's do this. So for this first example, we need to multiply two binomials. So here's the first binomial, 3x to the ninth plus 2x. And the second binomial is 5x squared plus x. So in order to multiply these correctly, we need to do every term in this first set of parentheses times every term in the second set of parentheses. So we're going to first start with doing 3x to the ninth times everything in the second set of parentheses. In other words, we're going to distribute that 3x to the ninth to the second set of parentheses. So first of all, 3x to the ninth times 5x squared. Well, 3 times 5 is 15, right? So we say 15. And then x to the ninth times x squared is x to the power of 11. So 15, x to the 11th. All right, good. Now we have, let's see, 3x to the ninth times x. So that's going to give us 3x to the power of 10. So 15x to the 11th plus 3x to the power of 10. Okay, good. We're about halfway done. At the very end, we do need to remember to combine any like terms before we finish. So now we're going to do the 2x times each term in that second set of parentheses. So 2x times 5x squared is going to give us 10x to the power of 3, right? 2 times 5 is 10. X times x squared is x to the power of 3. So we're going to say plus 10x to the power of 3. X to the power of 3. Okay, good. Now lastly, 2x times x is 2x squared. So we're going to say plus 2x squared. Now the next question is, can we combine any like terms? Now remember, like terms are like terms if they have the same variable and the same exponent. Here we have an exponent of 11, here we have an exponent of 10, here we have an exponent of 3, and here we have an exponent of 2. So we cannot simplify this expression anymore, and that is our final product. All right, cool. This next one here is going to be a little bit more complicated because we have some negatives, and we also have a trinomial in the second set of parentheses as opposed to a binomial. So once again, we need to do each term in this first set of parentheses times every term in the second set. So we're going to start with the negative 2g to the sixth and multiply it by every term in that second set. So negative 2g to the sixth times 4g to the seventh. Okay, that will give us a negative 8 something. So we're going to say negative 8. And then g to the sixth times g to the seventh. That will be an exponent of 13, 6 plus 7. So negative 8 times g to the power of 13. All right, next we have negative 2g to the sixth times 3g. That's going to give us a negative 6. And then we have an exponent of 6. Let me first write the negative 6 here. So we have negative 6 what? Well, g to the sixth times g is going to be g to the power of 6 plus, remember there's a 1 right here as the exponent on the g. Right there, we have a 1. So it's going to be 6 plus 1 is 7. So we have negative 6 times g to the power of 7. Now we need to do the negative 2g to the sixth times negative 4. That's going to give us a positive 8 something. So we're going to say plus 8. And then g to the sixth, we also want to remember that we have this is like saying minus 4 times g to the power of 0. So g to the sixth times g to the 0 is just going to be g to the sixth, right? So we have 8g to the sixth, 8g to the sixth. So now we've multiplied this negative 2g to the sixth times every term in that second set. So now we're going to do the same thing, but with the 3. So now we're going to say 3 times 4g to the seventh is going to be 12 something. We're going to say plus 12. And then we have, after this 3, think of the 3 as 3 times x, I should say g, 3 times g to the power of 0. So we're just going to take this variable and exponent and put it after our coefficient. So it's going to be 12g to the 7th. Okay, good. Now we need to do 3 times 3g. Well, that's going to be 9g. So plus 9g. And lastly, we have 3 times negative 4. And then we need to make sure to combine like terms. So 3 times negative 4 is negative 12. Now, do we have any terms that have the same variable and the same exponent? We do, right? Here we have a g to the 7th, and here we have a g to the 7th. So we can combine those. But we have no other like terms other than those two, right? Because here we have an exponent of 13. Here we have an exponent of 6, 1, and 0. So we're just going to combine those two like terms with the exponent of 7, and then we'll be done. So let's rewrite. Let's see here. Let's rewrite the negative 8g to the 13. We can move this up here now. So we still have negative 8g to the 13. And we also want to make sure that these are in descending order. The exponents are in descending order so that we have standard form. So after the 13, we have exponents of 7. So the negative 6g to the 7th plus 12g to the 7th is like saying negative 6 plus 12. That will give us positive 6g to the 7th. So right here we have plus 6g to the 7th. Okay, what's the next biggest exponent? We have a 6, right? So we're going to say plus 8g to the 6th plus 8g to the 6th. And then let's see here. If it helps you, you can cross out what we've already written. So you know, as we get longer expressions, sometimes that's helpful. So you can cross out the negative 8g to the 13, the negative 6g to the 7, 8g to the 6th, 12g to the 7. We still have the 9g. There's no like terms as we talked about, so we can just say plus 9g. Cross that out. And we still have minus 12. So eventually, at the very end, we need to write minus 12. Minus 12. Okay, now let's double check that we have standard form. So we know that we already used all the terms. So we have 13 right here, then 7, then 6, then 1, then 0. So good. We are in descending order, speaking of exponents. So there's nothing else that we need to do in order to achieve standard form. And there are no more like terms to combine. So with that, we are finished with that problem, and we are finished with the video on multiply binomials by polynomials. Remember to always be clever.
Hey, hey.